I'd like to welcome you all to the performing a cybersecurity risk assessment as a component of a process hazard analysis webinar. The opening slide here indicates a couple of technical things that you should be aware of. Please mute your microphone. The audio is being provided via internet. Don't hesitate to provide me with any questions that you have by making use of the Q&A tab at the top of the screen. I'll read the question and then get you an answer. The session is being recorded and will be available on the exida website, as will all the slides in this presentation to all the registrants that are attending today. So this is a webinar on performing that cybersecurity risk assessment. My name is Dave Johnson. The presentation was put together by Hal Thomas, one of the partners here at exida. Hal unfortunately had a scheduling conflict, so I'm doing the presentation for Hal today. A little bit of background on exida. We are a worldwide company dedicated to improving safety and security and availability to our clients in their automation systems. As you can see, we have offices in North America, South America, many places in Europe, Australia, and Africa. Our main corporate headquarters are located in Sellersville and just outside of Sellersville, Pennsylvania, in the United States, and just south of Munich, Germany. exida has an industry focus. Then you can see there are a variety of industry sectors that we address. We address the complete supply chain of functional safety in multiple sectors: automation, automotive, nuclear, and the process industry. We provide training services, software tools, consulting, all related to functional safety and security, from original equipment manufacturers to end users. exida does have a wealth of information that we've published in the form of books and other literature, information on our website. We've authored probably most of the industry references for automation safety and reliability. We're constantly studying the safety and the security industries and working to codify that information and make it available. Any of these references are available on our website and also through Amazon. The exida certification process itself starts and is based on ANSI accreditation. And it goes right through multiple layers of accreditation until we get to our actual certificates that we issue for both safety and safety certifications, and as well as cybersecurity certifications. And we are backed up by ANSI, as is shown here in this slide. This is a little bit of a bio on Hal Thomas. He is the originator of this slide deck. Hal's been in the industry for many years, primarily with Air Products. He's been with exida for a number of years and has pretty extensive credentials and background in doing these kinds of certifications, and has tremendous knowledge in this area. My name is Dave Johnson. I've been in software engineering for many years also. Fairly recent addition to the exida team as a senior safety consultant. I have worked in many different industries: the power control industry, the power industry, pharmaceutical, educational industry. So I have a long and extensive background in software engineering. There are several certifications that I have and am working towards. You might be familiar with some of those. So let's get into the objectives of the webinar today. we are focusing on cybersecurity lifecycle awareness and inputs to perform a detailed cybersecurity risk assessment. We want to go through the basic methodology of doing this risk assessment, which is designed to identify potential cyber hazards to the system. All of this is done in the context of a functional safety certification, and we're looking at the cybersecurity life cycle within that functional safety certification. So to start with, let's take a look at the 61511 Basic Safety Life Cycle. There are three major components of that life cycle: analysis, realization, and operation. Now, analysis is broken up into several different areas that have to do with the process hazard analysis, allocation of safety functions to the risks identified in the analysis, and then finally identification of the specific requirements for those functions. Once the functions are identified, you want to go through and design them and test them and install them, and then ultimately the safety functions go into an operational mode. The yellow columns on either side show activities that extend throughout the life cycle, the management areas, the basic planning of setting up your functional systems, and verification-related activities. Typically, this life cycle will refer to an entire project from beginning to end, what is known as a greenfield project, something that's just starting up. However, very often, security tends to be something which is analyzed after installations are in place. But it's important to understand the overall life cycle to get the context of when you are performing your individual cybersecurity assessment. So if we take a look at the cybersecurity life cycle, the green boxes that you see at the top are the focus of this webinar. The print is a little fine there, but hopefully you can read that. I'll read them out for you. The first green box says process plant design and scope definition. So in other words, to do your cybersecurity analysis, you have to have a very clear picture of the hardware involved and the components that are involved in the safety system that you're in the process of protecting. So you want to perform the high-level security risk assessment on that collection of equipment. And then that fits in with your overall process hazard analysis, the cybersecurity portion of that. So if we take a closer look then at the cybersecurity analysis phase itself, prior to conducting the detailed cybersecurity risk assessment, you need to perform your high-level risk assessment to provide input to that and determine what portion of the hazards that you've identified are specifically security related. So in performing a hazard operational analysis as well as a layer of protection analysis, you go through and identify those components which are specifically cyber related, and then we'll continue the analysis further once those items are identified. So as input to this scope and definition, you start with your basic corporate and site policies, any specific requirements, the zone and conduit drawings, which identify the specific architecture of the system that you're doing the analysis on. You want to bring into account any regulations or standards as part of that whole analysis process. Out of that, once you complete the cyber risk assessment, you have a set of security level requirements, and then you go to determine whether or not the risks that are involved meet your corporate criteria. So you want to make sure that you're in line with any corporate risk standards that may be in place. And then, of course, you document those requirements. The reference there, 62443-3-2, is the zones and conduits specification, which is in the process of being defined by one of the ISA committees. So the inputs, as I mentioned, to your security risk assessment are any policies and procedures that you have that are based that your corporation has in place. RAGAGEP, otherwise known as Recognized and Generally Accepted Good Engineering Practices, RAGAGEP, is basically the starting point. Here's where you want to identify all of the major guidelines within the organization and bring those into play. You'll take the high-level risk assessments, the zone and conduit drawings that you previously created, and any HAZOP or layer protection inputs. So those are the basic components that go into the risk assessment, the cyber risk assessment that we're going to perform. So in terms of identifying at a high level, you first want to take a look at what threats you may experience, the cause of those threats, any potential concern as a result of the threat, what kind of frequency or demand may occur on your system as a result of those threats, and any kind of consequence or severity of the threat if it in fact occurs. So if we take the first one on the list there and look at the threat of potential data modification in your system. So what could possibly cause that threat to occur? A malicious third party, disgruntled employee, or malicious employee. Is it a concern? Well, yes, it is, because someone could get in there, modify your data, corrupt your system in some fashion. However, one might consider this to be low demand because hopefully you have corporate policies and proper authentication in place to prevent this kind of thing from occurring. And depending on the nature of the data which is modified, that could be any severity. In case in this example, it's considered to be medium severity. So once you have this information in place, that identifies the basic requirements of your system. You want to make sure that you're clear on the architecture of your system, and the best way to do that is by identifying zones and conduits, which are the connections between zones. So this is a high-level architecture diagram showing the corporate enterprise zone, the site or business LAN, site for the business LAN, the DMZ. There's identified in this particular drawing a control room zone, a safety instrumented system zone, and a field zone. Now, this could very well be a typical installation. However, the first thing that would obviously be of serious concern is what appears to be a direct internet connection to your field. This is certainly not a good practice. Likewise, the demilitarized zone, the DMZ there, seems to have no components in it, and with a wire going straight from the business LAN into your controller. So obviously this is not an optimal drawing here, but could very well represent a particular installation for someone who hasn't paid attention to or had any particular concern, a security-related concern. So how do you make use of the process hazard analysis then? How do you leverage it? So what you want to determine is whether or not any of the hazard events or the layer of protection events vulnerable to a cyber attack. So in other words, can any type of a cyber attack come in there and disable or disrupt any of the existing hazard or layer protections that you currently have in place? Are any of the safeguards that you have in place vulnerable to cyber attack? And what are the possible consequences if an attack did in fact occur? So in going through a methodology to make use of this information, again, you start with that high-level security risk assessment. You determine the scope, make sure that you understand the exact nature of the equipment that you're in the process of reviewing. You go through your zones and conduits drawings, again, to identify the architecture of the safety system that you're in the process of protecting. You're going to set up a team of individuals that will assist in that entire process. So the team has to be provided with the information. And you start through your iterative process of selecting a zone, a particular node, let's say, within the zone, select a threat that you've identified, identify causes, consequences, and countermeasures, and to try to determine a resolution or a means for addressing that threat. And then you go back through and look at more threats within that zones, look at more nodes within that within the zone, and then ask the question whether or not all the zones have been evaluated. Once all that information is gathered, then you put together some basic security recommendations. Now, this is a lot of information to try to put together. And there are right, so if we look back at the zone and conduit drawing that I previously showed, in the case of this example, we're identifying the scope as just the business LAN zone, as well as the control room, the control sys, and the field zone. We're excluding from this particular example analysis the corporate enterprise. So this is a lot of information to put together. And you can do this all manually. There are tools that are available to do this. Exida happens to have a tool called CyberFacts, which does a very good job of helping you organize all this information. And the following slides here are a couple of screenshots from CyberFacts showing how all that information could be entered into your system. So you start out with identifying the zones, and as you recall, we had a business zone, which is actually slightly obscured by the drop-down there. But there's a process control zone consisting of your basic process control system, as well as the safety instrumented system, and then the field equipment. So what you're doing to start out in this particular tool is identifying the hardware and the interconnection of that hardware. So you have your architecture built into the tool. From that point, as indicated in the flowchart previously, we want to try to identify causes, consequences, and countermeasures. So if we take a look at as an example, the sys controller that you see there and the malware, here let me point that out just to make sure we're in the correct place there. Possible malware that could get into the system. It could get there as a result of, let's say, third-party injection of the malware or a malicious employee. And if we just take those two possible causes and take a look at the consequences associated with those, in the case of this particular analysis, there could be a potential toxic release with multiple off-site consequences, potential to cause extended plant shutdown, and the like. So your team is putting together a consequence as you go through the exercise, first based on zones, then looking at causes of an attack that could come in, the possible consequences of that. Again, the next slide, right. The next slide, we'll start going through the consequences. And in that, in this particular slide, we're showing potential description of the consequences, There is a category. This tool happens to be highly configurable. The S and the B's that you see in the category there have to do with system and business. However, if you use this tool, there are many other categories that could possibly be defined. Likewise, severity and risk, you assign to these as you consider each individual possible consequence. And then once all the consequences are put in place, you want to take a look at what are the potential countermeasures that could address those consequences. So as a potential countermeasure against loss of system access and productivity, okay, let me just check that off so that you can see that there. One of the things, there's 3 things that were identified by this team that could be a potential countermeasure. That would be setting up an internet firewall, having password protection, and installing antivirus software. So again, depending on how you have the tools set up, there are a variety of different categories or attributes that you can associate with those. And there's also a place where you can enter in a description. So you can see in even a relatively small system, there are a significant number of consequences and countermeasures and severity and risks and likelihoods that you can associate with those. So there's a huge amount of information here that has to be compiled, and this tool does a great job of making that information easy to enter into the tool. And then there are a whole series of reports that come out of there that can assist in the further analysis process. Let me just add one additional thing here, the description that I mentioned before. So that description can be associated, sorry, that was, description, and then there are recommendations also that you can put into the system. And these would be possible, solutions to the potential risks that you have previously identified. So how do we make sure that we're successful in this exercise? You need good information about the process, your cybersecurity process safety information. You need to understand clearly what your hardware is, what possible entry points for threats where vulnerabilities can be injected into the system. And you also want to make sure that your technical team that's doing this analysis has good knowledge of cyber risk assessment methodologies, what we're talking about here, any IT networking, and again, knowledge about your control systems and specifically your safety system, your associated safety system. So all these components need to be in place in order for that hazard, the cyber analysis, cyber assessment to take place and be successful. So once again, if we check through that work methodology, you have a little bit better idea of what's involved. Again, we just go through this briefly. You want to conduct that high-level cybersecurity risk assessment, which is your overall guidelines to continue the process. You want to narrow your scope down to the specific system that you'll be working with. You want to create those architecture drawings, zones and conduits. You want to get that information to your team, and then one by one you want to go through the zones, any nodes associated with those, and look at the threats, document the causes and consequences, and identify countermeasures. And again, that's an iterative process that you'll go through, and you'll compile all these recommendations into a large set, and then have to identify the most severe problems or the most severe consequences, and implement recommendations associated with those. So in summary then, you can see that the risk analysis is just a component of the overall process hazard analysis, that is the cybersecurity risk analysis. The initial scope needs to be built on a foundation of, recognized and generally accepted good engineering practices, RAGAGEP, standards and procedures. The high-level security risk assessment allows detailed risk assessment to focus on what's important. So once you have your system decomposed into easily manageable items, in other words, specific consequences, specific threats, it makes it easier to focus just on those. And then once those are compiled together, you can look through and find the most severe. Detailed cybersecurity risk assessment identifies weaknesses in the proposed or existing design or operation relative to risk. And again, the perspective of this is a green field. So the thought process is that you can go in and build all these things into the original system, as opposed to having to go in at a later time and retrofit any of the countermeasures or recommendations that you have put in place. I see a question up. Let me pause, take it just a moment to answer the question. Okay, so there's a question that says, here we are, do field devices that are smart, for example, heart-enabled, pose additional threats to a safety instrumented system? Do you recommend against smart devices in SIS applications? Well, the problem with extending your field bus to hard, Profibus, Modbus, any of those kinds of devices is you open up a new port for potential threats. So depending on what your architecture is, or perhaps the security associated with the actual installation, yes, this could be a problem. So most safety systems deal with relatively simple I/O devices. I guess we can't necessarily recommend against them. However, they do pose additional threats to the system because they become additional potential vulnerability ports where threats and threats or vulnerability, it could identify additional ports where threats could enter into the system. That's great. Thank you very much for that question. So in summary, I guess I did go through this in summary. I have summarized at this point. So are there any additional questions? Just let me point out here that if there is something that has not been covered today or that you think of perhaps later after the webinar later today, my contact information, email us up there, and if you'd like to contact Hal and either both of us, those are both email addresses where we can be reached. So I'll pause just for a moment to see if any additional questions come up. And I hope no one is currently typing feverishly to enter in another question. Thank you very much for that one question that did come in. Again, if there are any additional information that you are interested in, let me refer you to the exida website. There's a wealth of information on there, both in recorded webinars, as this one will be recorded and posted on our website. Literature, various white papers that have been written, and numerous other references. So please check there or send Hal or myself any additional questions on this topic. Thank you very much for your attendance, and have a great day. Bye now.